We will now discuss the solution of a problem from the section Binomial Theorem. The problem is related to an application of Binomial Theorem. This question has appeared in the Joint Entrance Examination Main held on 29th June 2022 in the second shift. The given question is, let n greater than or equal to 5 be an integer if 9 power n minus 8n minus 1 is equal to 64 times alpha and 6 power n minus 5n minus 1 is equal to 25 beta, then alpha minus beta is equal to, we are given four options. Option A is this one. Option B, option C, and option D. We are given the integer n, an integer greater than or equal to 5, and it is given 9 power n minus 8n minus 1 is 64 alpha and 6 power n minus 5n minus 1 is equal to 25 beta. Then required to find alpha minus beta. We now discuss the solution of the problem in detail. We are given n, an integer greater than or equal to 5, and we are given 64 alpha minus 9 power n minus 8n minus 1 and 25 beta is equal to 6 power n minus 5n minus 1. We first take the first identity, that is 64 alpha is equal to 9 power n minus 8n minus 1. Now, by looking at the options, it suggests that we write 9 power n as 1 plus 8 power n and expand by means of the binomial. Then the powers of 8 will be coming out, and from this second one expand 6 power n as 1 plus 5 to the power of n by means of binomial. Then you will get powers of 5. So in the answers we see the powers of 8 minus the powers of 5 are appearing. Therefore, this may be the possible way of working out this problem. Therefore, we take the first one, write 9 as 1 plus 8 whole power n minus 8n minus 1. Now apply binomial. Write the binomial expansion. This will be equal to sigma r is equal to 0 to n ncr into 8 power r, that is the expansion, minus 8n minus 1. So this is what we have written. Agreed. Now we write the first two terms exclusively, then write the sigma notation from r is equal to 2 to n. So that will be equal to r is equal to 0, that is nc0 8 power 0, r is equal to 1, nc1 into 8 power 1, and then sigma r is equal to 2 to n ncr 8 power r minus 8n minus 1. Now nc0 is 1, 8 power 0 is 1, 1 minus 1 cancels. nc1 is 8, is n into 8, 8n minus 8n, they cancel. So after cancellation, we are left only with the sigma. That is sigma r is equal to 2 to n, ncr 8 power r. Agreed. Now, r is equal to 2 means it starts from 8 square onwards. 8 square, 8 square, 8 cube, 8 power n expansion will come. So in all these things 8 square is common. So take 8 square common. So 8 square is taken out. Sigma r is equal to n NCR into 8 power r minus 2, because we have taken out a 8 power 8 square out. So this is the one. So now what we have is 64 alpha is equal to 8 square into sigma r is equal to 2 to n NCR into 8 power r minus 2. So this 8 square and 64 cancels, and we will be getting alpha is equal to sigma r is equal to 2 to n NCR into 8 power r minus 2. Agreed. Now similarly we take the second one. 25 beta is equal to 6 power n minus 5n minus 1, and use the same technique. For 6 we will write 1 plus 5, and to the power of n we write 1 plus 5 to the power of n minus 5n minus 1. Apply the binomial, write the binomial expansion. Sigma r is equal to 0 to n NCR into 5 power r minus 5n minus 1, and write the first two terms exclusively, then write sigma r is equal to 2 to n. So that is NC not 5 power 0, that is for r is equal to 0, plus for r is equal to 1 NC1 into 5 power 1, plus sigma r is equal to 2 to n NCR 5 power r minus 5n minus 1. NC naught is 1, 5 power 0 is 1, 1 minus 1 cancels. NC1 is n into 5, 5n and 5n cancels, and you are left with sigma r is equal to 2 to n NCR into 5 to the power of r. In this expansion, r is equal to 2, that is 5 square, r is equal to 3, 5 cube, so on and so forth. R is equal to n, 5 power n. So in all these things you can take out a 5 square common. So you will get 5 square into sigma r is equal to 2 to n NCR into 5 to the power of r minus 2. Agreed. Now we have 25 beta is equal to 5 square into sigma r is equal to 2 to n NCR 5 to the power of r minus 2. So 5 square and 25 cancels, and you will obtain beta is equal to sigma r is equal to 2 to n NCR into 5 to the power of r minus 2. So alpha is here, beta is here, and required to find the value of alpha minus beta. Therefore alpha minus beta is equal to the first sigma minus the second sigma, and this is equal to sigma r is equal to 2 to n NCR into NCR is common, so 8 power r minus 2 minus 5 power r minus 2. Now let us expand. So r is equal to 2, so that will be NC2 into 8 power 2 minus 2 0 minus 5 power 2 minus 2 0. And r is equal to 3, NC3 into 8 to the power of 3 minus 2, that is 1, minus 5 to the power of 3 minus 2, 1. So NC2, NC3, NC4, that is r is equal to 4, NC4, 8 to the power of 4 minus 2, 8 square minus 5 square, plus so on and so forth. At the end, for r is equal to n, so it will be NCN into 8 to the power of n minus 2 minus 5 to the power of n minus 2. So this is what. So 8 power, now you come to the beginning, that is NC2 into 8 power 0 is 1 minus 5 to the power of 0 is 1. 1 minus 1 cancels, and this will be 0. So the summation starts from NC3 onwards. So that is equal to NC3 into 8 minus 5 plus NC4 into 8 square minus 5 square plus so on and so forth, NCN into 8 to the power of n minus 2 minus 5 to the power of n minus 2. So this is our answer. Let us look at our options. So our answer appears against option C. Therefore, the answer to this question is option C. So that is the detailed discussion of the solution of the problem from the section Binomial Theorem and its applications. And it is definitely an easy question. I am sure that you have understood the solution of this problem, and I wish you all the best. Thank you.